Hello everyone, welcome back to our Algebra 2 class. Today we are going to continue our conversation about the sequence and series. We actually finished, all the topic about the sequence. We know the two type of the sequences we were studying are arithmetic sequence and geometric sequence. If you need any help or you need to review these topics, please make sure to check the previous videos about this, topics. Today, we are going to move very soon to the last topic series. But before that, we are going to introduce a new symbol you are going to see in this unit. This symbol is called sigma notation. Let's check how it looks like. So sigma notation, also called summation notation. So if you pay attention to this word, you probably notice there is a word here hidden here is sum. So sigma notation, or we call summation notation, is actually a symbol to help us to figure out the sum. Okay, so it's actually adding terms. And this this letter is actually a Greek letter, is a capital letter of the letter sigma. And let's check what are we seeing here and how do we understand the different parts of the sigma notation. So as you can see, this sigma notation, we have something on the bottom and something on the top. And also we have some expressions next to it. So let's check one by one of that. So the bottom you see is the counting number for I. I starts at 3. And so when we see that, we are going to say, oh, I is going to start with 3, and then we just keep counting and stop at 5. For example, this meaning I is going to equal to 3, 4, 5. So some student might ask, so I is only for the counting number? Yes. So we can use we can use N, we can use K, you can use all different kind of letters, but we always put a counting number. Where do you start? Where do you stop? Where do you end? And for example, if I put I equal to 1, then you just keep counting until you see whatever you stop here. And during this one, we are actually adding expressions. What we are adding? We adding to I. So what does that mean? That means I'm going to adding to I, and I will be equal to all these three values, meaning I'm going to add 2 times 3, 2 times 4, and 2 times 5. And that's it. That's how do we understand the summation notation, or we call sigma notation, is another simple symbol to indicate a list of the sum. And this sum can follow certain pattern. We can use an index number to represent this sum. And we know adding them together is same. 2 times 3 is 6, 2 times 4 8, 2 times 5 10, and then we're just adding them together. So that's a sum of this. So that means this expression, let me use a different color, the expression is 24. Okay, so this is how do we understand the summation notation. So you may wonder, since this is just adding terms, what's the point I have to write this way? How about we just list everything together like this? So sigma notation, the higher level math you probably see this notation a lot. It's quite easy when you have dealing with, for example, I need to do a list of long terms, sum of long terms, and instead of list every single terms here, I can just use summation notation to rewrite this in a simple way. So for example, as you can see, I'm adding 1 2 3 4 5 and continue until adding 10. So that means if you consider this is the first term, this is the second term, I just consider until n. So like I said, you can always using sigma notation to write it, and you can use any letter. So in this case I'm going to use n. N start with the first number, 1. But remember, I'm actually, using counting number, so the first term is 1. So n is 1, then until n is 10. So all the terms is I just adding all this counting number, so I'm adding n here, and that's it. This is, how do you do it? So you are indicating, oh, I'm starting with n equal to 1 until n equal to 10, and every single number I'm adding is just a counting number. Okay, so same thing here. I'm gonna still using, let's use k this time, so you are familiar or you get used to see different letters in this case, but you know what's going on. Again, I'm going to rewrite this in the sigma notation here. The way you write it, I'm just repeating this. Sometimes it's like, sometimes students write like this way or like this way. It really doesn't matter how you write it. It's like, I wouldn't say this letter E, but, if you like this way, but it's just like, M or W is like a lighting down this way. So this is how you write it. And then, so let's check how do I use index number like a counting number to show that. So the first term is 2, 4, 6, 8, 10, and until I, adding to 24. But remember, you have to use a counting number, so you have to convert it to the certain relation about like starting with k. The first term is 1, then 2, then 3, then 4, then 5. We just continue. And let's check what are the relations. So it seems that everything is just double, right? 1 times 2, 2 times 2, 3 times 2. So everything is double. So I know the last term is actually 12. So it seems that k starting with 1 until 12. And every single thing I'm adding the even number. So I'm adding 2k. So if you want to list everything out here, you will know this expression have 12 terms, and each term is a double the number of the counting number. So that's why this all even number here. Okay, so that's one way, is to save our space, to save our energy. Instead of writing the whole long term of all the the sum of such a long terms, we can just use a symbol, which is called sigma notation, to rewrite this sum. Now we are going to do some practice regarding this symbols. Let's check the different symbols here and different expression to see how do we do this kind of thing. Of course, you are always welcome to stop the video, to pause the video, and work on these questions on your own and come back later to see if you have a same answer. If you do, congratulations, you totally mastered this notation. So let's check the first one. So the first one, we know the k starting with -1 and then ends at 3. So that means it's going to go -1, then 0, 1, 2, 3, right? It's just like when you look at the number on the number line. So starting with -1, 0, 1, 2, 3, right? This is how to do it. And then let's check what are the things we are adding. We're adding k squared. So that means every single number here, I'm going to square the number it. So the first one is -1 square, 0 square, 1 square, 2 square, and the last one, 3. Oh, I'm sorry, I made a mistake here. Square, square. So some student might argue, hey, you said it's starting with counting number, the -1, of course, is not counting number. So more precise way is more like integers. So k is an integer as you indicate, but it's always, the way you count it from the, from where it starts. Then you just look at the position or like on the number line. And this is all the integers. You just keep moving up until you touch the stopping part. And then let's just, do the math here. So -1 squared is 1, 0 squared is 0. So we can just skip that. 1 squared is 1, 2 squared is 4, 3 squared is 9. And all we just need to add every one here together. 1 plus 1, 2. 2 plus 4, 6. And then final answer is 15. Okay, that's it. Now let's check this one. So this one, let's use a different color. Put a bar here so we know there's different space. So this one is I starting with 1, 2, 3, 4, 5, right? It stop at 5. So what are the things we are adding? we adding negative 1 to the I power. What does that mean? I'm going to rewrite everything just using, it seems like it's always negative 1 something, but it's negative 1. The first power, second, third, fourth, fifth. This, this sequence is actually quite interesting because if you see all the numbers here, we know negative 1, the first power is negative 1, but then the even power is always give you positive, but the odd power always give you negative. So it's like alternating, right? So positive, negative, positive, negative, positive, negative. It's like a switch. So, like, positive is on, negative is off, so it's like a switch. Now we know negative plus positive is always 0, 0, so everything is 0 in the front. The left part is only negative 1. Okay, so that's this one. Let's check the very last one. So last one, again, let's check how do we start and ending. So I start with 1 and 2, so it's only 3 terms, 1, 2, 3, right? So what are the things we are adding? We're adding I times I plus 1. So all we need to do for this expression, we just replace I as 1, I as 2, I as 3. So it's going to be 1 times 1 plus 1. That's when I equal to 1, right? And then when I equal to 2, it's going to be 2 plus 1. When I equal to 3, it's going to be 3 plus 1. Remember, I is changing here, so it's changing as I goes up. So now we just need to do 1 times everything is, itself, 1 plus 1, 2. 3 plus 1, no, sorry, 2 plus 1 is 3, 3 times 2 is 6. Remember, you do parentheses first, then you multiply, then you do the adding next. So sometimes do not be confused about the order of operations. 3 plus 1 is 4, 4 times 3 is 12. Now add them together, you will get the answer 20. Okay, so that's all the 3 examples I want to share with you about the sigma notation. If you did pause the video before, I hope you have the same answer as mine. And double check if you do have a different one, then check which step you might make mistakes, okay? Thank you so much for starting this topic with me. And very soon, we are going to introduce the very last topic of this unit. Just stay tuned to check out these new lessons. And thank you so much for studying this topic with me. Take care, everyone.